question is about the reaction between copper and nitric acid. And copper react with the concentrated nitric acid according to the equation. So you can see here copper, it's a solid, and nitric acid, it produces copper nitrate, water and nitrogen dioxide. So this is a balanced equation. 3.2 gram of copper is reacted with 0.40 mole concentrated nitric acid. Work out which reagent is in excess. Right? So now the idea of this experiment is this. So we have nitric acid and then we add piece of copper. So the copper react with the nitric acid and it produces copper nitrate, water and nitrogen dioxide gas. So which one is excess? Nitric acid or copper? Right? So for example, further understanding this question, here is a beaker and the beaker contain we can't take a beaker actually, so we had to use a kind of a round shaped flask, and we can add the nitric acid, and then this is connected to a tube containing water, because the nitrogen dioxide is a toxic gas, so it is not good to inhale this gas. So either we have to do this reaction in a fume cupboard, or then we can collect this nitrogen dioxide into the water and it's not going out. So then if we had a very tiny, let's say, so that's a nitric acid, and we have just a very small piece of copper, right? So, or we can add a large piece of copper, example like this. So when we add the different amount of copper, so we're going to see whether nitric acid is enough or not enough, or copper is too much or too less. So that's the idea of this question, right? Now let's try to solve the problem. Now first thing we have to do, 3.2 gram of copper is reacted with 0.4 mole concentrated nitric acid. And the problem of this question is they are in two different units, right? So you know that when you want to compare anything that exists in two different units, for example, one is centimeter, one is meter. You can't compare the units, you can compare the numbers because units are different. So what we do always, we bring either to centimeter or meter. So here we also do, we have to do all the same thing here. We have to bring the unit to the same units, right? We have to bring the numbers to the same unit. That I use this formula, the number of mole equal mass divided by, now that's a copper is an atom. So copper is atom, so then I use atomic mass, relative atomic mass of copper. Right? So what is the mass we have? 3.2 gram. 3.2 gram. And now I'm going to convert this to the number of moles by dividing the atomic mass of copper is 63.5. Right? So then you can get this also from the periodic table. That's atomic mass 63.5. Right, next I'm going to calculate this. So I'm going to divide 3.2 gram. Let's do it. 3.2 gram divided by 63.5. Right, I get 0.0503. Just I round it up to the 2 decimal points, 0.05 more. So that's a very simple calculation. The gram converting to the mole. Now, what I can do now, I can write both again. So I don't have space here, I write down now. So this one 3.2 gram is now 0.05 mole. And nitric acid, right here now we can see the four nitric acid molecules react with copper. So then 0.05 going to react with 4. So that is 0.20 mole. So finally it's 0.020 mole. Okay, now 0.05 mole copper react with 0.020 mole of nitric acid. So then we have excess, so it's a 0.40. So we have 0.40 mole. So that means nitric acid is excess, so it needs only 0.20 mole, but it has 0.40 mole originally in this reaction. So that means the nitric acid is the excess in this reaction.
Go,